All right, so Kui, let me know when we're live on YouTube.
We're live.
Okay, great. Thanks. Hey, everybody. Welcome to episode number 4. I guess season 1. We are going to be talking about prompt engineering today. This is actually a part of a series that started out with, how to automate your job in business with ChatGPT. And starting in the last session, we're doing a dry run of an in-person boot camp. So we're covering all the topics that we would cover. And last time we talked about the fundamentals of large language models. We will review that for those who need to catch up just quickly. And then we'll dive deep into prompt engineering. And I'm going to go ahead and bring up my screen here. Yeah. And for the benefit of those that may be listening to this on YouTube or on podcast, I will try my best to make sure that if there are any visuals, that I explain them in detail. Because I know that I listen to YouTube videos all the time when I'm taking a walk. No Code Data and I, LLM Inside Bootcamp, we're going to be holding an in-person bootcamp in Santa Clara, San Francisco Bay Area in June. We have a date, and we'll put the details up as soon as we get the Eventbrite ready. The fundamentals of prompt engineering, I will cover just enough to give you, I think, what you need to go forward. But with any skill, you probably want to practice. In fact, anything you will want to practice. And there's more that everyone is learning, because this is a 6-month-old skill, basically, that is coming from both amateurs in the sense that they're just learning on their own, sharing with other people. There's lots of crowdsourced sites where you can see how other people, prompt with GPT or other systems. And then there are also several academic papers that are coming out, and there are a few that come out every week. So I imagine that if we do this series next month, there will be changes to it if there's anything substantial. In fact, every day I just have to spend a couple of hours keeping up with the latest in the open source world related to LLMs, in the commercial world, and then the academic world, because all of those together are a very powerful combination. I believe that the next frontier in AI is prompt engineering, and computer languages. If you programmed maybe 50 years ago, the way you used to program was using punch cards. They were literally like index card sized, and there were strips of them that you would punch, and that was the programming language. And then eventually you started to be able to type, and there were really low-level computer languages like assembly, and then there were higher-level languages like C, and then there's Java, and there's Python, and there's even a concept of a 4th-generation computer language where you would describe the application in very high level, and then it would create the application for you. I think the ultimate computer language now is language, because you can basically describe what you want the computer to do, and it's able to do it. And I'm not saying that all of the other computer languages are not useful. They have their place. They do certain things. Like JavaScript allows you to make websites that are interactive. Python allows you to interact with databases. And a large language model is not a replacement for those things, although it can simulate those environments. It won't replace them, right? But what it can do is help you interact with those technologies. And we'll cover one of the use cases where you can use prompt engineering to create code for you, for example, right? Well, you wouldn't run that code on the large language model. You would run it on the framework that language runs on. So if you ask it to create HTML, it will work in a browser. If you ask it to create Python, it will work on Python interpreter. Right? If you ask it to make a SQL query, it'll make a SQL query that'll run on a database. Shameless plug, we work for a lot of amazing companies and brands around the world. Kono is a initiative inside the Anand Corporation, and we are always looking to help clients with their global real-time data platform needs. And in the past, we've done AI integration in the form of ML ops and improving the performance of machine learning at scale, both on the training and on the inference. So when our world got upended with LLMs, we realized that this is the future, and we're here to help whoever needs. The bootcamp information is available at kono.io/bootcamp. You can also see the links on the YouTube and eventually on the show notes in the iTunes application or podcast application. The bootcamp is supposed to be for people that have some background in software and data engineering, and they don't necessarily need to have background in data science or machine learning, although that could be helpful. And goal is to show you what you need to know from a foundation perspective. So today, for example, one of the sessions would be foundations, fundamental prompt engineering, and then I would say 50% of it is on actually looking at example applications, let's say in the no-code world or in the full code world or in the enterprise. How do we implement these type of LLM inside applications? And this is the outline. Sections 1 and 2 are basically the theory and patterns. Sections 3 and 4 are the hands-on. I would say section 3 is more for showing you what's going on, and then section 4 is to build your own. So the agenda for the bootcamp: strategy and theory, LM design patterns. You'll get a good idea of what's happening, and you know what? I realized that every time we do this, we're going to have to keep updating that material because new stuff comes out. And then no code, full code LM stacks, what's out there, what's open source, what can you get started with right now, and building your own custom chatbot with your own data, I think, is the ultimate. I wouldn't say it's the easiest thing to do for somebody who hasn't done it, but in the world of LLMs, it is the most practical, most accessible way to really squeeze the power of machine learning in this new way of doing things, which is LLMs. Today, we're going to focus on prompt engineering, as I mentioned earlier. What is prompt engineering? Distilled, the fundamentals of prompt engineering, some magic patterns and techniques, and then some resources to learn. And I'm always learning on a daily basis, so I would recommend all of you also do that. In fact, in preparation for this presentation, I must have looked at maybe 60 or 70 different sites, and soon we will be exposing that knowledge base where we continuously add links. Right now, that knowledge base is available to the people who are on the Kono Discord. If you would like an invitation to the Discord channel, put it in the chat, and then basically we'll send you an invite. Just give us your Discord username. It's actually your username plus a number, or just leave us your email address and we'll get in touch with you. Prompt engineering. Well, what is prompt engineering? What is specifically LLM prompt engineering? What are the benefits, right? Why do I need to know this? And then why is it important in general for industry, for people. I look at it from the perspective that it's going to make people's jobs easier. But there's other factors in terms of why it's important in the overall ecosystem. Prompt engineering is, basically the art and science of talking to new AI. Generative AI is a category of AI that includes large language models, but it also includes text to image models like Stable Diffusion, DALL-E, Midjourney. There's another one called Blue Willow that I've been using. And LLM is a text to text generative AI that you give it text and gives you back text. And then there are some things called multimodal generative AI, meaning it can take in pictures and video and text, and it can at least understand and give you text. And some of them can actually also create pictures for you. A prompt is basically what goes into an AI like LLM to create things. And what I mean by things, it's basically text coming back. But if you ask it to create a blog post, it'll give you text. But if you ask it to create a blog post in Markdown, it'll give you headings and subheadings. And you can also say, make me a strategy, for example, for SEO, and it will make a table of all the major topics you should cover and what the audience is, and what type of focus keywords you should be going after for that particular blog. So depending on what you ask it, it will create the thing, but ultimately it's creating text, right? And right now that's what it's limited to. But if you work with a prompt to create something like HTML or to create something like a CSV, and you save it in that format, then that becomes the end product that you can give to somebody else. And we'll talk a little bit about how you can structure the prompt to be able to do that. But there is this balance of it, that it's an art and craft, or an art and science. An art being that, when you look at a piece of art, it's unique. It is something that particular artist became good at. But there's a craft in the sense that it can be taught to other people, like the craft of creating tables, like physical tables, like a carpenter. A carpentry is a craft, but there's an art in the sense that how do you design the table, but how do you make it? You can teach that to somebody else. So there's a big part of prompt engineering that we're going to cover is really the craft or the science of it. And the science of it is also how we can repeatedly get those results. And as I mentioned earlier, the academic world is trying cool stuff, and they publish papers all the time. So it's always good to kind of be tapped into that. From a boot camp that I attended, I guess a month ago, almost, prompts are magic spells. And basically, Charles from the FSDL group was saying the reason he calls them magic spells is that you kind of have to get to becoming a good prompt engineer by trying some tricks, and you put something in there and something magical comes out, right? And little changes could give you amazing, much better results than you would imagine, and you'll see what I mean by that. So what happens in a prompt what happens in an interaction with an LLM is the prompt goes into the language model and it creates text. So what are the benefits? Well, it's accessible. You don't need to be a machine learning engineer or a data scientist. In fact, you can give it machine learning type problems. You can give it data sciencey problems, it'll solve it. But the way you give it that problem is in plain English, and then you give it some data to do something with it, right? The economics, it's much cheaper to learn how to tune your prompts and give that prompt to the LLM that's already been trained than if you had to train it yourself. It costs millions of dollars to train large language models. It costs a few $100s to tune them, to fine tune them. We covered a little bit of that last session. But prompt engineering, meaning taking your prompt, tuning it by adding context and data that's yours, you can get it to give you good answers, to give you good outputs. And the only thing that you really spent is your time, crafting that prompt. And it's repeatable. If you come up with a good prompt structure, you can templatize it and you can give it to other people to use. You can also put it into an API. You can put it into a system that chains different prompts together. So knowing how to engineer prompts overall, I would say that's the way you get involved in LLMs today. Very few people I know are actually spending the time to spin up their own local LLM from one of the open ones. And there's reasons for that. And that's really covered in the LLM Inside Bootcamp, where we do a walkthrough of enterprise systems where the data has to be managed securely. But even then, right, whether you're using an OpenAI API that's publicly available, or using Cohere, which is another one, or you're using, let's say, stable LM's LM model in your own data center, you still have to learn how to engineer prompts. So hopefully that convinces you. So what is the important things you need to remember about prompts? Well, first of all, it's what do you want? Ultimately, the model is doing something that you want. And really, there's just two types of interactions. One is a question. You ask a question and it will give you an answer, right? It completes that answer for you. The other is it's an instruction, and an instruction is you tell it what to do and it does it for you. And you may say, you could basically take a question and make it into an instruction. Well, of course. But can you take an instruction and make it into a question? And there's a reason we just put them into those two categories. And it doesn't mean that you can't combine these, right? So we can combine instructions with questions. But you have to ask, what do you want? And the main components of a prompt are basically the instruction. Could be a question, but it's an instruction. What needs to be done? What do you want? The context, as in more information that would be useful for the LM to give you a better, better answer. The context could also be data from your system. And then there's the input, in the sense that, is there anything that you, given that instruction, given that context, what is it that you want from that, right? So that could be a question, or it could be another instruction. And then there's an output, in the sense that, how do you want this output? And you can put an indicator to say, this is where the output comes. And if you think about it in these kind of steps, what you can do is to actually repeat the creation of prompts. And you can also think about reusing different contexts with different prompts, right? So that's why it's good to kind of break it down. You may be asking an LM to do a different task, but the context is going to be the same. So for example, you may say, give me a natural language query, which is a task. And then you would say, the question from the user is this, and you put it in the natural language query. And then you would say output indicator, the SQL for this natural language query. Well, if the system doesn't really know the schema of your database, it's going to just make up an SQL query, right? So in the context, you may put in, well, this is what the tables look like, right? And then finally, the more clear you are, the more specific you are, the better the results. And I would also say be practical. The practicality comes down to the limit of the token length. So GPT-4 has like 32,000, but they only allow you to do so many interactions per minute. GPT 3.5 has, I think, 8,000 or 4,000. So if you wanted to do something like to write a 50,000 word book, unfortunately, it can't do that in one sitting. You have to actually break it down, and you have to say, these are the different chapters, and these are the different chapter outlines. And then You have to give those chapter outlines and say, create, XYZ, right? And that is also part of prompt engineering, which is breaking down a very big problem into smaller and smaller prompts and then chaining them together. Whether you're manually doing it in ChatGPT interface or you're automating it with Python, prompt engineering is not just the creation of a prompt, it's how do you automate the execution of prompts in sequence, in hierarchies, in parallel. Let's get a little bit deeper. We're going to do a quick review of what LLMs are and how they work so that you can understand why prompt structure has to be the way that they need to be. So what do LLMs do? This is again from last session. They predict words. And they've been trained on just terabytes of data from the internet, books, articles, websites. And that data has given it a probabilistic model where if you say, after the game we went, it could potentially give you any word in the English language, right? It could give you mouse, or it could give you home, or it could give you eating, or it could give you hiking. So it could be after the game we went hiking, after the game we went eating, after the game we went home. Those are more likely, so they're scored differently, and so they are given as potential candidates. And it used to be the first LLMs that were created, when you gave it some prompt, it would give you several answers back. And you could say, oh, I like this one. And that type of data, as it came back, people were able to make better and better LLMs. And I'm not going to get into how they're trained so well now, but ultimately that's what they're doing. They're predicting words. They're giving you the best next word. And then they take that and they run it again. So after the game, we went home, and then what comes after that? Right. As we've already talked about, and as you already know, LMs have a lot of capabilities. They can take language and translate it. You can make a chatbot out of it. Like you could make something like ChatGPT with ChatGPT's API. There's reason for that. You could use it for content creation. And I'm playing around with it for generating code or taking requirements and making them into specifications for a lot of software development lifecycle. So as long as the input can be put into text, the output can come back as text. You can do anything. And as we all know, HTML is text. SVG, which is graphics, is text. Mermaid.js, which is a way to design charts, visual charts, but it's text. Plant UML is text. So it's not just about creating blog posts, right? It's about taking an input, structuring it to get it to come out with something that you can use for some other process down the line. But even if you don't think about prompt engineering in that you'll probably say, like, I don't necessarily need to know how to program, but I would like to learn how to prompt engineer so I could be a better, prompter in ChatGPT. That's the reason why you still need to know some of this stuff, right? The better you understand how the LLM works and how to structure prompts, the better you're going to be at, basic 101 ChatGPT user interface. And as we get through this series, you'll find that you don't have to necessarily know how to program. As long as you know how to prompt and use some no-code tools, you could actually get a pretty good result without learning how to program in Python.
Hey, Raul, before we go to the next slide, we had a quick question from the chat. What was the way or tool you got started with prompt engineering, and did you track your prompts and qualify the responses?
Sure. Yeah. So earlier, before a lot of tools came out, I was basically keeping track of it in a Word document. And then I found a tool called Every Prompt. And in Every Prompt, you can create a prompt and then test it with different inputs. And it keeps history of the answers. You could change the models. You can also use the playground inside OpenAI. But Every Prompt for me is a really simple tool, and it's free, and you can put your OpenAI key in there and basically, go to town. And you can track. By the way, the other thing that it can do is like you can actually make an API from your prompt, and then see as people use your API, what is the input and output. So Every Prompt is the tool that I was using for that to actually, and it actually has the ability to train also. I haven't paid for it, but you can give feedback to the answers back to Every Prompt, and then it does something in the back end. I don't know how it works, but basically, supposedly, it'll tune your prompts. Okay. But you don't have to use Every Prompt to just do prompt engineering. You can use the playground at OpenAI, and you can use ChatGPT, of course. Oops. So what do LLMs do? It's the last kind of review slide from before. LLMs, they narrow the possibilities. Every single word that you give in your prompt is narrowing the number of potential documents that comes back to you. And so if you imagine that an LLM that has no intelligence, right? If you give it some request, it could potentially just give you chaos. You give it, hey, what's the weather today? Which probably wouldn't know that anyways. And it would say A, B, C, D, 1, 2, 3, right? Now, to me, that's chaos in the sense that it's characters, it's English characters, but it's chaos, right? Now, potentially, let's say it does have some understanding of words. Technically, like a not so good LLM, you ask a question and it gives you, I would say, it's garbage, right? They're using English words in the sentence that it gives back to you, and there's potentially that the value for that is probably pretty low. But as you get better and better at creating your prompt, you're basically narrowing from the responses that are probable to the responses that make sense, to the responses that make sense to you, to the responses that are really good for you, right? So LLMs, what they do is, given anything, they're trying to give you responses that make sense, the best sense that it possibly can, right? That's what the LLM has done. It's already been trained for that. But you can tune that LLM by giving it basically more words. More necessarily isn't good. I would say better words in the prompt will give you better responses. So, each model has a token verse, meaning all the words that you're putting into the prompt and all the words in the English language, they have broken it into these tokens. And tokens are not words themselves, but parts of words. And GPT-4, for example, has 100,000 tokens, right? And when you type in a sentence, it breaks those into certain tokens, and the position of, or I shouldn't say position, there's a number associated with that token, right? The sequence of those numbers for your prompt has a most likely document that comes after it. And that document is basically the most likely tokens that come after it. So if your words in one prompt start with, after the game we went, is, let's say, prompt 1, or after eating dinner, right? Technically, one of them will probably more like, after dinner we went to sleep, right? Or after the game we went home. And as you continue to elaborate that prompt, it'll give you a better answer. there's a possibility that both prompts will give you the same answer, but it's very, very unlikely, right? So if you're prompting with similar prompts and you're getting similar answers, that's to be expected. If you are trying completely wildly new things, and that's really what's good in experimentation, try moving words around, try moving the structure around. You're basically changing the way the LM is going to give answers back to you. I see a question. Are words basically tokens? I keep seeing the word tokens seemingly used as a metric of calculating horsepower of some sort. So words are not tokens per se. So let me give you an example of a very early LM where you would give it, let's say, different names, and you would say, here's 20 names of boys, of Russian boys, for example, right? Give me 10 more names of Russian boys. And they would basically give you names. Well, in that system, the tokens are actually characters, A, B, C, D, E, F, G, etc., right? Or let's say it's Cyrillic characters. And in the machine, in the LLM, it's actually keeping track of what are the most likely characters that come after a particular character, right? So vowels, what come after vowels, probably consonants, what come after consonants, probably vowels again. Or if it's near the end of the word, a boy's name will have certain characteristics versus if it's a girl's name, it'll be something else. So in some LLMs, that early LLMs, and you can actually do that. They can go look at a video, how to build GPT-2, and it's like 400 lines, and basically does that. It predicts names. But in that, the token is actually just characters. In a large language model such as GPT, the tokens could be as simple as the or a, or it could be like I had shown a screenshot of it last time, but it could be some programming language syntax, for example, because it's only going to, like, that particular token is only going to come in that particular programming language, for example, right? It's not going to be reused, whereas the word the could be used in a comment inside a programming language. It could be used inside a blog post. It could be used inside a poem, right? But it's not the word itself. It's just the best way it could split up the English language plus programming languages, because it's also looked at all those things. And then the reason, I would say it's not a metric for calculating the horsepower, because the horsepower, I would say, is the length of tokens. It's not even the length of tokens. It's how many predictions it can do in a certain amount of time, right? And that's basically to deal with tensor processing units or GPUs. But internally, it's not. It's even more granular. It's doing it at the tensor level or the matrix level, right? Way we see it is we can give 4,000 tokens and get a response back of 4,000 tokens. And for us, it seems like, well, that's the power of the system. But the reality is really, I think, beyond the number of tokens, is the quality of the sequence of tokens, right? There are models from GPT, from OpenAI, for example, Text DaVinci 02, and then there's Text DaVinci 03. They take the same amount of tokens, I think, but the quality of the output is just much better. So we talked a little bit about, earlier, like, what are prompts? They're either questions and answers, or they're instructions. So, for example, you can say, what is a large language model? What is 2 + 2? Why is the sky blue, right? That's a question you expect an answer. An instruction is where you give it a verb, write a 50-word description of a large language model, calculate 2 + 2. So basically, you could take a question and make it into an instruction. I explain in simple terms the color of the sky being blue. But an advanced instruction would be, act as a high-level software engineer. And then you would give it the problem, and then you would say, give me a solution to this problem, right? Or classify this text that I'm giving you by identifying the keywords in this text. Now, that's a problem that we could give it to, like a traditional, a traditional machine learning model, where we say, find the keywords for this document, right? And it will basically give you some words back, right? And like this is a classification problem. This movie is almost as fun as watching paint dry. You can give it to a classifier model, and it will tell you if the sentiment of this text is positive or negative or neutral, right? Well, you could actually tell the LLM to do the same thing. You could say, classify this text. Now, what the classifier can't do is you give it a question and it gives you an answer. What the classifier can't do is you give it an instruction and it does stuff for you, right? And that's where the generative AI is going way beyond traditional machine learning, is that machine learning has been used for natural language processing in various ways. Like, for example, you would classify text and find keywords, put that in a search index, or you would vectorize, and we still vectorize with LLMs. You vectorize some document, you put it into a vector database. When somebody asks a question, you vectorize the question, you find the similar documents, right? Those are using traditional machine learning models. But those can't do what the LLMs can do, which is create things out of seemingly thin air. So people use prompts for various things. They use it for content generation. So you could say, I want you to basically write an email, right? But you would say, tell Dan I'm going to miss the meeting today, stay home sick, ask him if he needs me to send the latest report. And you say email : which is your output indicator, right? Dear Dan, I'm sorry to say I won't be able to make it. So basically it's writing an email for you, right? That's content generation. You can also say, write me the SEO strategy for X topic, right? Create sales letter for for these notes that I took. Create a requirements document for these notes that I took, okay? You can use it for question and answer. You can use it as like a personal assistant. But all these are basically under the hood. It's the large language model. It's just completing the text for you. So what is the difference between these types of use cases? It's the structure of the prompt, right? It's how you give it the initial text that changes the behavior of what it gives back to you. You can do popular instructions like summarize, paraphrase, find people, places, and things in this text, analyze for sentiment in this text. Or you can have domain-specific instructions, such as write an SEO strategy for X, okay? But that's a very simplistic domain-specific instruction. If you wanted to make it even more specific, you could give it a better context, and you could say, a solid SEO strategy has the following components. Write me a SEO strategy for X, right? Then your prompts are even better. So when I think about a prompt, I kind of think about it like a function. So in programming, let's say in Java, when you make a method, you say, here's the output type. Here's the name of the prompt, or the name of the function. And it has certain inputs, or sorry, certain parameters. So there's an input and then there's a context, right? And then you have instructions for what the function needs to do, right? So when I think of a prompt, I'm thinking about how am I making a function where I need to define what type of output. I need to basically figure out the instructions. What is this thing going to do for me? What is this prompt going to do for me? Is there any specific context that I need to give it? And the context could be, as I said, these are the elements of a good SEO strategy, or it could be data. It could be something that you pulled out of a SQL Server database or a vector database like Pinecone or search index like Elasticsearch, and you give it relevant information, right? And then this is useful, although it's not needed. You clarify the input indicator, meaning here's the input is about to come here, right? And then you clarify the output indicator, which is, this is the type of thing that I want. And then your input is, what is the changing element of that function, right? What is the changing element of that prompt? a good prompt is reusable, right? And what makes it reusable is that everything here, instruction, context, input indicator, remains the same. The output indicator probably remains the same. And then your input changes. So the example I'm showing here is classify the text into neutral, negative, or positive. And this includes the instruction and the context. So the context is basically, it should be neutral, negative, or positive. The input indicator is just text colon, and then I can put 5 words in here. I can put 50 words in here as long as it's within the token limit. So my text input here, I say, I think that AIs are useful. And then I would say the output indicator is sentiment colon. So what I'm expecting is sentiment colon negative, sentiment colon positive. If I were to replace this text, I think that AIs are useful with something else, the prompt would behave the way almost like a computer function would behave, right? You're giving it an input, you're giving it an instruction, then you're expecting an output. Here's another example. Extract entities such as people, companies, and places from HTML. And in the input indicator, I say, here's the HTML. And then my input would be the raw HTML that I grabbed from somewhere. And then I say the output should be in JSON, which is a computer data format. JSON object, JSON stands for JavaScript Object Notation. It's used everywhere. And why would I want it in that? Well, maybe I want to take that information, like who are the people, what are the places, and do something specifically with person, colon, Rahul Singh, I just want the person's name, or company, colon, Anat, I just want the company's name, right? And this is the fundamentals of, this is the anatomy of a prompt. Instruction, context, where is your input coming in? What is your input? And then what is your expected output? And that's it, we're done. Just kidding. So what's been happening in the last 6 months or so is a lot of these magic patterns are coming out, which are basically techniques, prompting techniques. And I'll cover a list of them, although I won't have time to go through every single one of them. But we'll talk about 3. Chain of thought, APE, which is short for automatic prompt engineering. I think, yeah. And then React is basically not the JavaScript front-end framework, but reasoning. It's short for reasoning and action. So what do people do in terms of prompting techniques? So as I mentioned earlier, summarization, right? Inference. So I'm going to give you certain things, and I want you to give me some information back that's not already clear in that, right? Could be classification. It could be, here's the notes from a meeting. Tell me what the final decision was. It can do that. So transformation is another use case where you give it, let's say, a bunch of unstructured text, and you say, paraphrase this for somebody who's got a high school education. Or it could be, take these bullet points and make it into a blog post, right? That's the expansion of it. But these are basic use cases, and a lot of people are already doing this. So what are the advanced use cases? And this is just 2 examples, right? Sequence of prompts together. So you use a super prompt to create topics for a subject. Then you use another prompt to expand each topic into an outline. Then you use another prompt to expand each outline item into a paragraph. And technically, you could do that manually, right? Get a list of 10 topics, go back, use your prompt, give me an outline, you save that somewhere. Now, if you can think like a programmer for a second, sequence the prompts together. Use super prompt to create topics of subject for a subject. Put that into a database. Next prompt comes along, looks at every item in that database, and in another field puts the outline. And another prompt comes in And for each outline item in that field, it creates a paragraph and keeps adding it to the database. And ultimately, you have a database, which is a book, right? So prompt engineering at the core level is one prompt. What does it do? Then when you combine prompts together, you can do superhuman things, like write a book in 30 minutes. In fact, this is one of the first things I challenged OpenAI to do for me, and that's what convinced me. I basically described this process. I said, here is a particular topic, and I basically described what I'm describing here. And I said, write me the code to do this. And it wrote me the code to do that. So I didn't even have to engineer that, right? I just had a pretty good prompt, and it was able to do that for me. Maybe one of these days I'll open source it. Connect your prompt to an external data system. That's the other really advanced way of working with prompts, where I didn't cover it earlier, but large language models have data that it's been trained from, I don't know, 2021 or 2022, right? It doesn't have data that's more recent than that, because that's the last time they spent millions of dollars to train it. So if something happened in the real world after that, and you need to ask a question about it, then the LM can't answer it. It will maybe make it up for you, like it'll hallucinate something. That's what it's called. It just makes up something, right? But if you give it relevant information, then it can use that as the context, and it can work with that to give you a better answer, right? So it's how many people in the company are on the Eastern Standard Time Zone? Well, LLM doesn't know your company's HR system, but you could break down that question into a query, talk to the HR system, and it'll probably give you, all of their locations. And again, I'm just making this up as I go along. You could say, here's a list of employees and their cities and states and country, and you just give that to the LM and see what happens. And it would probably be able to tell you that these employees are in Eastern Standard Time Zone. And that's the type of question it could not do unless you give it the data, right? It doesn't have that information in there. So this is a relatively short inventory of different, basically different papers that have come out. And what I mean by papers, these are like actual journal-ready papers being published by students, professors, academics. And I'm not going to go through all of them, but I do want to bring attention to three. Chain of thought prompting, commonly known as COT. You'll see it in a lot of places, so it's probably good for you to, understand what that is. Actually, a lot of these techniques eventually they use some element of COT, or they try to make it better. But before we do that, automatic prompt engineer, we'll talk about that. React, we'll talk about that. But zero-shot prompting is what most people are doing right now. You give it a question or an instruction, and it does stuff for you. Few-shot prompting is where you give it some examples, and then you give it a question, and it gives you an answer similar to the data that you gave it. And actually, people do cool stuff with few-shot prompting, like given a superhero name, come up with their origin story, right? And they give like Spider-Man, Superman, whatever, Wonder Woman, and then you give it another name, and they'll give you that in that format. So it's actually useful to get the same format. Those are pretty easy to do and easy to learn. You can see it everywhere. But learning chain of thought and learning React is probably the most useful, I think, advanced technique of prompt engineering. The automatic prompt engineer is I think it's got a lot of promise. It costs a lot to do it, but the promise is this. They say that the LLMs are actually as good as human prompt engineers if you use this method, right? So it's like saying it can do the prompt engineering for you. So chain of thought. So when you're doing a standard prompt, you say, here's my question, here's the answer, here's my question, what is the answer, right? LLMs really can't do good math, they can't, because they're not a math system, they're not a calculator, they're predicting words based on stuff they see on the internet. But what people have done is they've said, hey, this is a question, here's how I would solve it, and then this is the answer. And then if you give it the same exact question, it actually will give you a pretty good answer. Right? And that's basically called few shot. You give it a shot example to mimic. Okay. And this is, again, built up in several other techniques. Now, there's a zero shot version of chain of thought, and that's a different paper, right? It says large language models are zero shot learners. And what that paper says is that if you just add some words like, let's do this step by step, or let's think this through step by step. I'm like, literally, it's these words. If you put it into your prompt, it does a better job, right? So that's where I was coming back to what I was saying. It's like magic spells, right? If somebody figured this out, it's a magic spell. You put this at the end of your magic spell, it'll work better, right? And then chain of thought is also the foundation of the artificial general intelligence projects like AutoGPT, Baby AGI, because they basically are getting the LLM to break down a chain of thought first, and then those thoughts become actions in a series of tasks, right? And then all those tasks come back, and then it does the next step. Automatic prompt engineer basically says that it can achieve the level of a human level prompt engineer. And the way it does it is that given a particular set of words, it creates instructions via the LLM, evaluates them to then come up with the best prompt, right? So it's comparing itself with chain of thought, with zero shot chain of thought, right? And so some people have used, let's think this step by step, right? That has a pretty good accuracy first, and then second and third and whatnot. And then that got a pretty good, let's think, it's got a 57% accuracy. Whereas when it did its own, it came up with a much better prompt. It says, let's work this out in a step-by-step way to be sure we have the right answer. Now, the human did not create this prompt. The automatic prompt engineer actually created it. React is used by a lot of frameworks now, where what it's doing is it's taking a prompt and then figuring out with chain of thought what it needs to do, and then it continues to act on that in a sequential manner. Now, if you combine the reasoning aspect of it with the action of what needs to be done next with an external system, then you really get a powerful system. And this is different from just, I have a prompt, here's some relevant data I'm going to put into that prompt, and this is the output that I want, right? In React, what's actually happening is the system is given one prompt, it thinks about what it needs to do, and it starts to prompt itself or talk to other systems to get relevant data, and then prompt itself until it gives you the answer. And I shouldn't say Llama Index is a different type of system, but LangChain is based on this React concept. So this example here is that this comes from the React paper. Question is, aside from the Apple remote, what other device can control the program Apple remote was originally designed to interact with, right? So it says the answer is the iPod, and it's really not. And it's basically, if you give it just reason, right? Meaning Apple Remote was originally designed to interact with Apple TV. The Apple TV can be controlled by iPhone, iPad, and iTouch. You give it a little bit more context, it's going to give you an answer that's still incorrect, right? Now, if you say action, meaning I look for the word Apple Remote and it gives you some information, then you look for something called front row, couldn't find it, and then it finds front row software, and then it says that's discontinued, and it finishes, right? So when you combine, so without this React system, standard reasoning and action only, you're gonna get bad answers. But when you combine the reasoning with the action, meaning getting it from a different system, then you get a really good answer. So I need to search for Apple Remote and find the program it was originally designed for. So it searches, it gets a bunch of stuff, and in there it'll find front row media center. Now, how does it know to look at that front row media center? Well, that's the whole point of the reasoning in action, is that it is taking the answer that it comes back from an external system and it analyzes it as a context of a prompt, a thought. And that's why it's so good, is that it's continuously writing its own prompts, given the data that it comes up with and given the data that's coming from the outside world. We're almost out of time. So I'm just going to quickly go through the resources to learn prompt engineering, primarily crowdsourced prompt template tools, open source, and Discord channels. So ShareGPT, it has 240,000 conversations that other people have shared. ShareGPT was also used to create a fine-tuned model that's commercially available. The data from it was. OpenPrompt.co is another site that's kind of similar. AIPRM, I use that. It's a plugin for Chrome, and it's got about 3,000 prompts that are free, and then you can pay to get access. WriteSonic, I have not used it, but it looks kind of similar to AIPRM. There's public prompts, personal prompts. Literally looks like exactly the same thing. PromptPal is another one. So these tools are great because you can save your own prompts and you can share them with people. The reason I didn't put every prompt in there is that it doesn't have an aspect of like seeing what other people are putting there. But I like every prompt as a prompt manager, but you can use these plugins as a prompt manager as well. Now, I don't think you can use ShareGPT. ShareGPT is just like share conversations and find them. It's generally directed towards consumers. You're not really able to automate with these, right? You're just able to kind of save them. Open source, so you can Google awesome ChatGPT prompts, ChatGPT data science prompts. And as you can imagine, you can probably just search for sales and marketing prompts, and you can find some good answers. The OpenPrompt.co and ShareGPT raw data sets are also available online. Somebody scraped ShareGPT before they turned off the Explore function, but that's available on Hugging Face. And if you go to Google, GitHub, you can do the same thing. Just look for ChatGPT prompts, and you'll find there's lots of them in Chinese now because a lot of folks are using proxies to access ChatGPT from China. My favorite is Discord channels. I have been a Discord user for years, but I'm not a gamer and I'm not an algo trader, so I don't spend a lot of time in there. But ever since I got deep into LLMs, that's really the place to connect with folks. So if you just Google like ChatGPT Discord channels, you'll end up on a site that indexes them. And I think for prompt engineering, ChatGPT prompt engineering, ChatGPT itself, there's one called OpenAI, and that's really for OpenAI API users, but there's a few channels on prompt engineering. There's a channel for the subreddit of ChatGPT. And then if you really want to go beyond just prompt engineering and automating prompt engineering, then LangChain and Llama Index. And we have a new Discord channel that if you want, drop your Discord username in the chat or the comments, or drop your email and we will invite you. some key takeaways. Ultimately, a prompt is questions or instructions. There's a context. There's an input of like, what's the variable input? And then the output that you want. And then when you add chain of thought, the answers get better. If you just say things like, let's do this step by step, it automatically gets better. When you add reasoning and action with a system like React, again, this is the LLM React paper. It's the method. It can do amazing things. And so I would say just take a task that you do on a daily basis and use ChatGPT's native interface, chat.openai.com, and try to create reusable prompts. And if you're able to do a pretty good job, then maybe take a look at some of the tools, AIPRM, WriteSonic. I use every prompt. There's another one called Promptable. There's so many. PromptPal. Remember, this is kind of an art and a science. The science and craft part of it, people are doing lots of great research. That'll always be helpful, but nothing beats you practicing. Chat GPT LMs aren't just for chatbots. You can use them in automations. It is the next generation of computer programming. The sooner you start playing, the better you're going to get. So hopefully, you spend more time on it. And I think the most important part about this is that the science is the structures and patterns. The art is your knowledge and your experience. And your domain knowledge will make you better at doing it than anybody else, right? Like if you know something and you learn how to prompt engineer, you're going to be much better than if you know something and you're working with a quote unquote prompt engineer, because they just don't have the language that you have. So with that, thank you and dream big. We'll see you guys soon. Thanks for joining us.